Hey guys, welcome to the third episode of Linux Basics for VLSI. In this series, we are covering Linux fundamentals and features that are frequently used in VLSI. Today's episode will make you familiar with Linux kernel, various Linux shells, Linux file tree architecture, mounting and unmounting concept, repository concept, and software installation basics. So sit tight and enjoy the learning experience.
Hey guys, welcome back to the computer screen. So in today's episode, we are going to discuss Linux architecture inside out. What is Linux kernel and shell? Some famous shells in the Linux. TCSH, the favorite shell for VLSI engineers. Repositories and software installation in Linux. File structure comparison, Windows versus Linux. File tree structure in Linux. And finally, we will be discussing what is mounting concept in Linux. So, this is the menu for today. Without any further delay, let's begin. Linux architecture, inside out. You already have seen this picture in the thumbnail. So, let us start how the Linux works from inside out. If we think the inside thing, first, whatever physical thing is there, it is the hardware on which the Linux kernel is wrapped around. So the layer of Linux that is directly interacting with the hardware is kernel. Now this kernel has multiple processes, that is multiple running processes for various things. We'll come later. Multiple devices are connected, their firmware are also part of the kernel, and many external firmware which are installed by the user also stay at the layer of the kernel. Next, the file system. In Windows, you might have a concept of FAT, that is file allocation table, or latest you have a NTFS. So Linux also there is a file system called ext2. Obviously, don't worry, at later point we'll cover these things in this particular episode only. So that file system is taken care at the kernel level. Multiple device drivers also stay at the level of the kernel. So kernel also controls the driver and hence controls the external devices through the device drivers. Above kernel in Linux, we have the shell. So the shell is the word that you might hear, or you hear it more than anything because you hear the shell scripting. We have tickle shell, we have TCSH shell, we have bash shell, anything that you hear. The shell word you hear many times. Above the kernel in Linux, the layer that wraps around the kernel is shell. It is few familiar names like is TCSH, bash, CSH, TCSH, KSH. KSH is the corn shell. TSH and TCSH are C shell and tenise C shell. Bash is born again shell and TCSH you already know. This is the concept of the shell. Multiple shell names are popular and all popular names I have tried to keep in the same picture. The wrapper above the shell is called apps, that is software or application software. What we generally see in this layer is office software like LibreOffice or OpenOffice. Then we have NEdit is a text editor. Then we use the ls command to see the files. We use the gvim as a text editor. We use the Firefox for internet browsing. We use GCC for C compiler or G++ compiler. We use VLC to watch video or listen to music. We use gedit for text editor. So all these applications are wrapped over the shell. Let me bring my mouse here. Any particular code execution or instruction that is going from the apps layer, it will cross the shell and then it will cross the kernel and it has to access the hardware. It will access the hardware and then again control comes back to the apps layer. So this way to and fro the thing works. This is the Linux architecture inside out. I have explained you the various layers, that is hardware, above that kernel, above that shell, and above that all the application software, that is apps. We are done with this particular slide. Let us move on to the next slide. Now we'll go deeper in the subject. What is kernel? The Linux kernel is the main component of a Linux operating system and is the core interface between a computer's hardware and its processes. From the picture you already know that the kernel wraps around the hardware. Any hardware level communication, that is communication in the machine language, machine readable binaries that are done by the kernel. It communicates between the two and manages resources as efficiently as possible. You know, right? Any computer nowadays is a multitasking system. One particular OS might be running multiple softwares at the same time, whether it is your system software or it is a user, that is application software. Anything and everything that has to be managed properly, and that management is done by the kernel. The kernel looks after 4 main things. First, memory management. Keep track how much memory is used to store what and where. This is a very good thing because we are working on a particular application software, and that software we are saving some files. So at first the files are at RAM, and then they will go to the hard disk. At hard disk they will be stored as per the file system and the file tree structure. So all these things, the memory management is done by the kernel. Process management. Determine which process can use the central processing unit, that is CPU, when and for how long. So we have multiple cores for a CPU nowadays. The process management, any process may take 1 core, may take 2 core, or maybe all the core. So this CPU management and the core management, all these things are taken care by the Linux kernel. Device drivers as mediator or interpreter between the hardware and the processes. So all the devices, say right now I am speaking through a USB microphone, and that microphone needs a driver to run. So that particular driver is taken care by the kernel. System calls and security. Receive request from the service from the processes. There are multiple background system process runs that generally as a end user we do not see them. But if we try to list out all these processes, we can see what processor are running. So there is a command called top. If we run the command, we can see what all processes are ongoing. All these system calls are well taken care by the Linux kernel. In a nutshell, 4 things: memory management, process management, device driver management, and system calls and security. All these things are tightly managed and timely managed by the Linux kernel. We are done with this particular slide, so let's move on. What is the Linux shell? Well, this particular word shell you hear every now and then. This word you do not hear for the Windows. This word you hear for only the Linux system, because the shell concept, the name shell, belongs only to the Linux and the Unix systems. So this is a graphical representation where we access the shell. Generally here it is a terminal, you can see, and in this terminal we access the shell. Although this terminal is not the shell. At the command line, whatever command we type, those command goes to shell, and those commands also belong to the shell. In 80s and early 90s, every computer was command line based. Nowadays, you might not see computers which run entirely in the command line, but maybe 20 years ago or 25 years ago, that was the picture. That time, mostly the Linux operating system used to boot on the command line, and once it boot up, only the command line is with you. I myself learned in that fashion. Nowadays, you have the VMware. There you can load the Linux GUI. From there, you open a terminal. So this is the very much difference. We're done with the first point. The Windows had a forefather named as DOS, which was a complete command line operating system. So why I mentioned this point? Because you might be wondering that Linux has only the command line. No. Before the Windows 95, there were the major operating system was DOS. The full name of it is Disk Operating System, and it was also like the command line. That time when the DOS was there, the DOS used to boot in a command line fashion like the Linux. Similarly, Linux GUI, called the X Windows, had the forefather called Bourne Shell, that is SH, released in 1989. Recently, whatever we use the GUI, it is called X Windows system in Linux. And nowadays, I have already shown in the last episode that there are P4 Linux desktops like Genome, XFCE, Plasma, all those things are there. Shell is a command line system software that interprets the commands and sends them to the OS. It is an interpreter between the end user, that is you, and the computer hardware. The shell accepts your commands and executes with the hardware. A shell provides the below thing, that is built-in commands, programming control structures, environment variables. Linux support multiple shells. Nowadays, default shell is the bash, that is born again shell. So it is a upgraded version of the born shell, that is bash. So all these things are there. So a shell will contain its own commands. It will give the programming control. I have made already a series on bash. So that is a favorite shell for the Linux programming. So there all the programming controls are very good enough. You can write a good script in bash and use it like any other programming language. Although it is interpreted, it is not compiled. environment variables are there, it's very much needed, and we know there are multiple shells. I'm not talking about anymore. So I think we have covered what is a Linux shell from the concept. Nowadays to the picture is also there where you will access the shell. So I think text and graphics both are done. So let's move on to the next slide. Some famous shells in Linux. Here we are going to discuss about few shells. Those are very much famous in the market and you may came across them every now and then. Although in VLSI, 1 or 2 shells you will be facing everyday work. However, if you are a Linux enthusiast, you might find all the shells to play around. The first thing is Bash, that is born again shell. Second is C shell. It's more like the C programming language. It's the scripting part. TCSH is the corn shell. And finally, the TCSH. You have seen the logos here or the names, whatever applicable. Now, we will contain a table. The first, we will have the shell name. Second, we will have the name of the developers. And the third column, we will have the location where it was developed. So here is the table. So let me bring my mouse pointer. So Bash, that is born again shell. It was developed by Brian Fox and Chet Frame in the location Free Software Foundation. C shell, that is CSH, was developed by Bill Joy and at the University of California. KSH, Korn shell, was developed by David Korn and location is AT&T Bell Labs. TCSH, that is 10x C shell, was developed by Ken Ger and it was developed in the location of Carnegie Mellon University. So you can see that the various shells were developed at various geographical locations also and from different teams. So that's why the Linux system is so much popular. It spreads around. People are enthusiasts. They still develop multiple distribution. They contribute for development of the Linux. And the great thing about the Linux, it is open source. So people can easily contribute. That's for this particular slide. Let's move on to the next slide. In this slide, we'll talk about the TCSH and we'll explore why this is the favorite working shell. That is your typing commands and all these things. Why it is favorite for the VLSI usage. So one point came here. First point is VLSI most used command line shell is TCSH and the most used programming shell is Bash. I have already created a series on Bash which is based on the programming language for shell scripting. The command line that is used day-to-day work is TCSH. Next point, TCSH is a great shell for those who are slow typists because TCSH sometimes gives auto completion if you hit the tab key. And the third point, which was already there, command line editing and the file name or command completion. So I have mentioned this already that if you type some amount of the file name or the command and then you hit tab, it gets completed in the TCSH. The fourth point is you can use the tab key to cut down the amount of typing you do, that I was saying. When you press the tab key in TCSH, we'll try to complete either a file name or a command. Most of the VLSI command line tools require login shell to be the TCSH. This is the industry use which I mentioned here. VLSI command line environment variables are easy to configure through set env variable, whereas the same thing is export command in the Bash. However, in the VLSI world, any manual if you open up, you will see that all the environment variables are set through the set env command. All the VLSI tools prefer the TCSH to be used. Proprietary software license manager work well with the TCSH. There are license managers because any of the VLSI tool, they are proprietary tools and they require license to run. The license will be configured by the environment variable and the license will be managed by the license manager. That is another kind of software that has to be installed separately apart from the basic software, and that works very well in the TCSH. So keeping all these points in mind, this is just to give you a snapshot why the TCSH is the favorite working shell, that is your typing shell in the VLSI. So folks, we are done with this particular slide. Let's move on. Bash, the favorite shell for programming in VLSI. And for this reason, I have created 4 episodes where in the first 2 episodes, I have covered basics, and the third episode I have covered the sed, and in the fourth episode I have covered the awk. So you guys can go ahead and watch those episodes because this 4 episode concentrates on the programming through the Bash shell and the 2 other tools that can be added with the basic Bash scripting, that is sed and awk. So folks, we are done with this particular slide. Let's move on. Repositories concept in Linux. Now, why I am keeping this particular slide is a very general concept, or it's a very much needed concept of the repositories in Linux. This particular terminology you will not hear if you are using Windows. Now here first we have a repository server where all the Linux basic file, all the packages, the installation thing, they will be there. It is maintained by Ubuntu, or it is maintained by the Debian, or it is maintained by the Fedora group. So all these groups, they will maintain their own repository server, from where you download a copy of the Linux into your local machine. After you install the Linux, whatever software you are installing through the command line, I'll come at those commands later on. Whatever software you are installing through the command line will communicate with the repository server and fetch the respective dependency packages from there, and finally install in your local machine. So this is the functioning of the repositories. So let us see in the text. Linux repository is a storage location from which your system retrieves and installs OS updates and application. Once you have installed, say, Ubuntu, every month you will get some updates, and those updates will be loaded on the repository server, from where you can download and update your local installation. Each repository is a collection of software hosted on a remote server and intended to be used for installing and updating software packages on Linux system. Now you might be wondering at this point why I am talking about the repositories, because many times if you try to install software manually instead of the command line or the RPM or Debian package, that time it will throw out an error. We are missing these packages. So for those packages you have to add the repositories first, and then you have to install them. In between also you have to update the things. This concept is necessary because this is a very far away concept from the Windows software installation, where you have only one file to install. In Linux, when you try to install a software, it will maybe in the background installing 5, 6 or 10 dependent packages on which the software depends to be installed or to be run, or both. So those things coming from the repository server. So this concept is very much needed, because you as a beginner, you want to install some software, and if you have to troubleshoot, you have to know this particular concept. Repositories contain thousands programs and relevant packages. Already mentioned the relevant packages, that means the packages which are required either to install the software or to run the software properly. Standard repositories provide a high degree of security, since the software included is thoroughly tested and built to be compatible with the particular distribution and version. This is another reason why the Linux is so much secure, because the software repositories are maintained by the respective groups like Ubuntu group or the Fedora group or the Debian group or the Red Hat group. They maintain these repositories. So the files staying there are clean, and hence it is very much secure that you can install any software from the original repositories without even thinking, because they will not contain any malicious code or something like that. And these codes are well tested by those respective groups. So that is why the repository is very much important, and hence Linux machine is considered as a much more secure system as compared to a Windows system, because in Windows you can download the file from anywhere and install it, but in Linux you must have the proper repositories from where you are installing. Forget about the RPM or Debian deb packages. I'm not talking about them. You can do that. However, they will also may connect with the repositories for dependent packages. You can expect the installer updates to occur with no unexpected side effects. This is the very much good thing. Apart from any security threats, they will not come. The security threats will not come if you are installing from a proper repository. And also you will not have a crash or something kind of stuff where you are installing from a repository. That means they are well tried and tested. Then they are uploaded in the repository server. I think this slide is done, and the concept transfer is also done from my side. So let's move on to the next slide. Software installation in Linux. So far we have become familiar with different repositories, hardware, kernels, and everything that is Linux inside out. So now let's look on to the fact how we can install the Linux. I will just exemplify here. I will not show any demo here. Later we can go through such installation, or you can go ahead and watch OpenTimer. I have already installed. There I have installed all the repositories first, and then I installed the packages. Okay, that thing you can go ahead and see. The OpenTimer installation. The video you can find in the static timing analysis playlist. So here, first for the Ubuntu or the Debian, these 4 commands we use. Let me bring my mouse. First one is the apt-get install, then we give the program name or the package name. And if you want to remove it, we get apt-get remove. We generally add sudo because any installation or uninstallation requires the root permission, and Ubuntu here it is sudo. sudo, and we use the apt update to update the packages and upgrade to upgrade the packages already installed. Say we have a package version 1.01, we get a 1.05. So for that upgradation, we use the apt-get upgrade. So all these 4 commands are used for the command line installation. I can tell you that the command line installation is much more easier than any GUI, because if some error is thrown out, the GUI will not give you the exact reason what is going on and why that installation has been stuck, but the command line will give you the message. So that's why the command line install I prefer, and I will suggest you that you go ahead and install it in the command line way, because you can troubleshoot if there is an error. At least you can copy paste the error in any search engine and you can find out from the respective Linux group forums what happened, because generally these are software errors and they are common and they are reported in the respective forums like the Ubuntu forum or Fedora forum. So we are done with this particular 4 commands. Let's move on to the next. So for Fedora or Red Hat, we have the yum. So yum install, then the package name, yum remove the package name, yum update the package name. So this is the way we do it in the Fedora. In SUSE, we use zypar. So zypar install, then the package name, and zypar remove the package name. For BSD, we use the pkg command. So pkg install, package name, pkg delete, then the package name. So this way we do it in the BSD. So mostly in this tutorial, I am using the Ubuntu distribution. So you can keep your focus here in these particular commands, which I will be using again and again. Although I have given you different flavors which are used just to have a broader picture and a bird's eye view how the installation is done in the Linux. So folks, we are done with this particular slide. So let's move on. Repositories are in Ubuntu. We have already discussed what is a repository and why we keep a repository. In this tutorial, I will be using the Ubuntu throughout. I am educating you through this particular slide what all repositories are there for Ubuntu. The first one is the main. This is the officially supported open source software. Canonical is the group which maintains for the Ubuntu. Canonical provides official support for these packages. Every open source software package included in the default installation is included along with some other important packages. So this is the purpose of the main repository. Restricted, officially supported closed source software, that is hardware drivers, support for the length of the release. Restricted, and this is for closed source softwares, this repository. Universe, community maintained open source. Community means I already mentioned that the Linux is an open source system and many people, they contribute to software, they help to enhance a software by their own contribution in the software code. That makes a community. So if such community exists for a particular distribution, say Ubuntu, all those contributions will be kept in a particular repository, and that repository is named as universe. The majority of the Ubuntu software comes from this repository. Canonical does not provide official support or updates. Since these packages are contributed by the community, hence the main group that takes care of the Ubuntu system, the Canonical, they do not provide the support here. Here you will get whatever is contributed and updated by the community in the universe repository. Multiverse, unsupported closed source and patent encumbered software. So those which are not supported by the Canonical or they are closed source or some patent is there. So all those software will reside on the multiverse repository. So I'll show you in the Ubuntu where you can see all these repositories later on the hands-on episode. So just for your knowledge, you can think the main, restricted, universe and multiverse. So the main is by the Canonical and the universe is by the community. Rest of the things are closed source. We are done with this particular slide. Let's move on. File structure comparison, Windows versus Linux. Here we have a table. File structure, I have 4 points here as a category on which we are going to compare Windows and Linux. So file system in Windows, generally nowadays you will see the NTFS. Earlier it was FAT32. Before the millennium, I think everything was FAT32. Windows Millennium Edition, everything is NTFS. In Linux, earlier it was XFS, then it was ext3 and then ext4. It is called extended file system. So it is also extended version 3 and extended version 4. They are termed as ext4 and ext3. So latest is running ext4. And in pen drive, you will obviously find either the FAT or the FAT32. That is the first category comparison. Second category is when we do a partition. So if we do a partition in Windows, generally our first drive is C, second is D, and third is E. Sorry for the typo here. And Linux, the same thing will come as dev/sd1, dev/sd2, sd2, dev/sd3. I'll come later to you all these names. They are there in this particular episode. Mounting point indicator. So we have CD-ROM drive, DVD-ROM drive, or any disk drive. So those will come with the drive letter C, D, E, F, G. And in Linux, the mount path is all under this slash. This is called root. I'll come later to this detail. OS installation location. In Windows, we have all the OS related files in the C drive, whereas in Linux we have all the files installed in the slash. This is called the root directory. We are done in a short and sweet fashion. What are the file system, what are the partition, what is the mount point loader, and the OS installation for Windows versus Linux comparison. This way you will be able to correlate concept of Windows that is already in your mind versus the Linux thing that is you are learning new. So this was the purpose of this slide. So let's move on. Overall file tree structure in Linux. So this particular slide is graphical only. So here is our root directory. First we have the bin, then we have the dev, then we have the etc, then we have the user, we have the home, we have the sbin, we have the temp, and we have the work. So under the root, we will have all these directories. These are major directories. However, these directories can have subdirectories. I am not talking about them because that will make your concept much more complex. And right now as a beginner, I will not make things complicated. Later, you can learn by yourself what are the subdirectories and all. Linux has a file tree structure as compared to the Windows. Windows, we don't see this kind of file tree or this kind of structure. There we see only drives, and each drive will have its own file structure. All these things you will see common in any of the Linux installation, whether it is Red Hat, whether it is the Ubuntu, whether it is BSD, whether it is Garuda. All these kind of Linux you will see these folders common, which will stay under the root folder, that is slash. The root is the topmost folder in which they will be there. So what these things mean, I'll come in the next slides. Let's move on in detail. The slash or the root directory is the topmost directory in the hierarchy. This is where all other file systems are mounted when the system boots up. Not to be confused with the slash root. Slash root, we have a separate directory. The only slash that is called the root directory, that is the system root. And the slash root, this is similar to a slash home directory, but for the root user or the super user, that is the system administrator. Next is slash boot. The slash boot directory contains all the files necessary for the boot up sequence of the system. Mostly consist of the bootloader, that is group, which is for the Linux systems, and the kernel files. So here all the boot related files are there. The slash bin. The slash bin stands for the binaries. It will contain necessary core utilities required to mount other directories. In most distribution, these also exist as a symbolic link as slash user slash bin. Slash dev. The slash dev abbreviates as devices. Everything is a file in GNU Linux, even devices. The hardware is represented as a special file. The slash dev abbreviates as a devices. The slash etc, that is generally the etc. This etc directory consists of system-wide configuration files and databases. Things are very straightforward, so I did not re-explain any of them. Let's move on to the next points. The slash user directory contains the executable binaries and other shared resources. The home directory has a folder for each and every user. So each user has a home directory for them. It enables to have user-specific configuration files. By default, each user has read and write access to their home directory and must need special elevated permissions modify files outside their home directory. The sbin. It is like a bin directory, but commands used by the system administrators consist of important commands for starting, maintaining, and recovering the system. So all the system related binaries will be stored here. The slash tmp. This is the place where the temporary files are stored. This directory cleaned up during the startup. So this is more like the temp directory of the Windows. If you are familiar, then you can correlate. Slash var. The var directory, which is the important information like caches, log files, etc. are stored. This is similar to the slash tmp, but the files aren't clear during the startup. So this is the difference between the var and the tmp. tmp is cleaned up at the startup, but var is not. Although it will contain similar files like caches, log files, and etc. So we are done with all these points. Move on for the next points. The /media, the mount point for the devices such as USB devices and other media devices. The opt is optional where the locally installed software exists. So this is for locally installed software. /mnt, temporary directories are mounted in the /mnt. I'll go in detail for the mounting concept later. Just for now, you can remember that the temporary directories are mounted in the mnt. For example, a dual boot system, you would mount the Windows partition as /mnt/Windows. The /lib. The /lib directory has some important C libraries required by the /bin directory. There also exist lib32 and lib64 depending upon the system architecture. It exists as a symbolic link to the user lib in most distributions. So I'll cover later on in this series what is symbolic link and what is hard link. These are all important directories that I have discussed under the file tree structure of a Linux. We are done. Let's move on to the next slide. What is mounting in Linux? Now this is a very different concept as compared to the Windows. Why? Because in Windows, if you insert a pen drive, right, or if you insert a CD, you can directly read it. Nowadays, even if you insert a pen drive in Ubuntu, it will sense it and it will automatically allocate it as a drive. However, at the background, the mounting is going on. Now, what goes behind the background, I'm going to explain here, because if you eject a pen drive, even it is physically connected, you cannot access it anymore. To reuse it, you have to exert and insert it again. That means you have to reinitiate the mount process. Now, this mounting is very much needed because in VLSI, you sometimes have to mount a remote disk to work there. That is the relevancy. That's why I have kept this particular slide. In VLSI, when you are actually working inside a company, your home directory generally do not contain much space. You have to mount a remote directory to the mount command and use it. And I think for ease, this mount command may be included in your CSHRC file. I'll come later on. That's what is a CSHRC file. But for now, you just become familiar with the mounting concept. Later on, you will find the usage. In Windows, where there is one directory tree, part storage component, that is hard drive, that is pen drive or SD card or DVD RW or external hard drive. So generally one particular tree, this is the structure. The Linux have a single directory tree as we have seen already. All accessible storage must have an associated location inside this single directory tree only. Mounting is the act of associating a storage device to a particular location or path in the Linux native directory tree. In Linux, you have a /root and inside that you have different directory, and this works like a tree structure. So whatever drive you have to include inside a hierarchy under this file structure. So mounting is that particular process. Let's say a CD-ROM device hardware is location. This is the physical location. /dev, dev is for devices, and then CD-ROM. And the chosen mount point will be /media, then /CD-ROM. The corresponding command is mount, then dev/CD-ROM, then media/CD-ROM. We have space in between mount and the next section and the next section to it. This way mounts a particular CD-ROM. After mount files inside the CD-ROM is accessible as /media/CD-ROM, then some directories I have put wildcard and some files which also I have put wildcard. So in this hierarchy, you will access the directories and the files inside. When you have finished using the CD-ROM, you unmount it as unmount /dev/CD-ROM or unmount media/ both will work. You can unmount using either of them. In GUI or GNOME desktop, you click on eject or safely remove. Comes with the right click context menu. This works as the unmount command in the background. After this step, although the CD-ROM is physically connected, you cannot access it until you mount it again. So this is the concept of mounting. And this way, the mounting and unmounting works in Linux. So this is slightly different from the Windows system, which keep in your mind. So we are done with this particular slide. Let's move on. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in comments in the comment section down below, and bye for today.